All right, so in this video, we're going to go through sample question 96 from the Society of Actuaries ExamP list of sample questions. Don't mind this torn out bit. I misspoke and felt like re-recording. So the question reads, a tour operator has a bus that can accommodate 20 tourists. The operator knows that tourists may not show up. So he sells 21 tickets. The probability that an individual tourist will not show up is 0.02. It's independent of all other tourists. Each ticket costs $50 and is non-refundable if a tourist fails to show up. If a tourist shows up and the seat is not available, the tour operator has to pay $100, which is or 100 whatever money, which is the ticket cost plus a 50 penalty to the tourist. We need to calculate the expected revenue of the tour operator. All right, so this is a very common type of question, mostly because this is also an actual strategy that airlines use when selling tickets. They'll overbook flights on purpose. So we need to figure out the expected revenue. Well, his expected revenue is actually going to be the amount of tickets he sells, which he's always selling 21 tickets, subtracted by the amount that he's expected to refund, right? So here's what we can set up. Every time he will sell 21 tickets at a cost of $50. So 21 tickets will be sold at a cost of $50 each, and that's going to be him making $1,050 for those 21 tickets. However, he might be required to refund $100 to a passenger if everyone shows up, right? But not every time, right? There's a specific probability that everyone will show up. Now, since all passengers show up independently from one another, and there is a 0.02 chance that a passenger won't show up, we can figure out the probability of all passengers showing up. Okay, so if there's a 0.02 probability that a passenger doesn't show up, there's a 0.98 probability that a passenger does show up. So the probability that all passengers show up, so probability all, should be equal to 0.98 times 0.98 times 0.98 21 times, or 0.98 raised to the 21st. And that is equal to 0.98 raised to the 21st, approximately 0.6543, around there. And just letting you know, I'm going to store this as X. So when I actually do my calculation, I'm not using this number. I'm using the more exact number, just so I don't end up with some weird rounding error, right? So that's the probability that all passengers show up. So we're going to deduct that cost he would have to refund, which is 100, from the total amount he made, but we'll deduct it only this amount of the time, 0.6543. All right, so doing 1050 minus 100 times this number, which I stored as X, I get 984.57 approximately, which rounds to 985, and it's choice E. Okay, simple as that. Overall, not too difficult of a problem. Very reminiscent to a lot of like binomial distribution type of questions, except this is insanely easier. We needed to find his expected revenue. So his revenue was going to be the amount of the money he made from all the tickets he sold, subtracted by the cost of refunding a particular passenger. He doesn't refund the passenger all the time, so we accounted for that. He only needs to make this refund about 65% of the time. And simply subtracted. All right, if there are any questions, throw it down in the comments. I'll answer to the best of my abilities. If this video helped you out, hit the like button, subscribe. That definitely helps me out. And if you want to see more questions like this, I got a playlist. Check it out. But other than that, thanks for watching, and I hope this helps.